Right, thank you. We're going to have a panel next focusing on RNG interconnection guidelines, gas quality, and other issues you have to deal with when you're talking about getting pipeline quality gas into your distribution or transmission system. The bios are in your program, so I'll just touch on briefly. I'll introduce all the speakers and then we'll go in series and then we'll have some questions from me and from the audience. Scott Reising is Senior Energy Engineer at Black Hills Energy. He's passionate about the central role RNG plays in sustainability. So am I, so I'm glad of that. He has about a decade of experience in renewable gas and has played a key technical and leadership role in the success of multiple renewable projects across the country. We then have Melissa Mauro, lead engineer at National Grid. She's been with the grid for 6 years now and is currently a lead engineer focusing on gas quality, odorization, and non-pipeline alternatives such as biomethane from anaerobic digestion, power to gas, and hydrogen injection. She was recently published as a chapter co-lead in the 2017 revision of the AGA Odorization Manual. And she graduated 2010 with a bachelor's in chemical engineering and got a master's in chemical engineering as well. Gus Simmons is director of bioenergy for Kavanaugh and Associates. He graduated from North Carolina State University with a degree in biological and agricultural engineering, concentrating in biological waste treatment. And upon graduation, worked in the agri industry, holding positions in design, permitting, and environmental compliance. He has assisted in many public and private entities in the development and implementation of systems to reclaim water and energy from various liquid waste streams. And then Nate Taylor, Commercial Development Manager for SoCal Gas. Nate heads up the team on biomethane and hydrogen growth initiatives. He previously held roles in product development and project management at SoCal Gas, as well as energy efficiency and demand response research in gas distribution engineering. He has a BS in mechanical engineering from University of California, San Diego. Please welcome the panelists, and we'll start with Scott.
Good morning. Just a brief overview. I'm with Black Hills Energy. We're a combined gas and electric utility. We're located, here's our footprint. We have about 1.25 million gas and electric customers. Just over 1 million of those are natural gas. As you can see, we have a pretty wide footprint, so when it comes to RNG, that's actually a great thing, as many of these states, as you can see, are highly agricultural areas, and so there's a lot of interest from our region in regard to producers that want to interconnect with natural gas utility. Currently with Black Hills, we have 3 interconnections right now with RNG producers. And the process that we started with is basically a very similar process, modified a little bit from what we use for large volume customers. Starting about 3 years ago, we had to begin somewhere, and there really weren't a lot of guidelines out there. I would say that this is currently under revision because we recognize that RNG projects are unique from normal natural gas projects, and we really need to do a better job of giving a good roadmap for our producers to understand how to enter our system. The pieces that go into our interconnection, there's basically technical pieces and agreements. With the technical pieces, we have a gas quality specification, gas quality monitoring program, which is a lot of tests and procedures. We have a basically automated system that works with shut-ins and letting people back into the system. And then we also have just basically the scope of supply that we're going to be providing for these producers. when they work to enter our system. The agreements are usually a gas purchase agreement, transport agreement, and facility agreements. Each of these agreements basically deals with different pieces of the project. For instance, the transport agreement is used to capture a lot of the O&M type costs that go into these projects. So there are going to be some consumables. There's going to be, technicians' time, checking calibrations, bringing in third parties when needed as well. And then the facilities portion really factors in a lot of those capital expenses that go into a project. So we run a feasibility model to determine, how much of the project is feasible within the, expected gas volumes that the producer is going to be providing. And then the remainder of that will take over a certain period of time. And every project is unique, so the dollars associated with it and the amount of time that we allow for that repayment to happen will vary from producer to producer. But that's how we end up reclaiming those costs to build out the interconnection. So looking at this, we really do need a new process, and we're working on it. Right now, these are some of the goals that we're really looking for. We've learned a lot in the last 3 years of bringing producers into our system. We found a few gaps that we want to make sure get closed. There were the initial project that we brought in, the first one, we really learned a lot. We actually learned that, to successfully execute that project in the timeline that we were looking for, really took some extraordinary effort by some individuals to make it happen. And the way that we look at it is whenever there's a lot of extraordinary effort needed, that means a better process is needed. And so we are closing that loop right now. So some of the basics, just a step-by-step roadmap for a producer. We want to clearly communicate all of the requirements up front, define each step in the process, identify, internal resources that are needed, external resources that are needed, essentially establish all those deliverables for each step in the process. And then the piece that we've really found was lacking, because every producer, they really vary from some producers who have done this, for quite a while, have a great organization and understand a lot of what it's like to work with a utility, and some that have, somewhat limited experience. And communications is really one of the stumbling blocks and one of those gaps that we found. So developing that communications plan up front is a key piece to this next step forward. And with that, I'd like to thank you and welcome any questions as we go.
I think we'll just go down the line and then we'll take questions.
Perfectly.
Where were you aiming it? Where did it work?
Does it matter?
I don't know. Big green
This one,
button
right?
is not working? Where should we aim it down here? This is not working to advance. Okay.
Did I do anything different than I did?
No, I pushed the button.
Okay. And after that, right?
Yep, perfect.
Ah,
All right, thanks. So hi everyone, I'm Melissa Mauro, and I am going to be presenting in regards to Northeast Gas Association's document. It's entitled RNG Interconnect Guideline for New York, and it provides a process for getting to yes when it comes to RNG interconnections. Closer? Is that better? Okay. All right, so a little bit about NGA first, since I'm speaking on their behalf. It's a nonprofit trade association. The local distribution companies in New England, New York, New Jersey, and Pennsylvania under their umbrella. Also includes several interstate pipeline companies and LNG and CNG suppliers. There's over 400 associate member companies within the Northeast Gas Association. And here's a link to their website if you are looking for any more information. Here are a few areas where NGA provides functions to enhance the natural gas industries, education, training, R&D, stuff like that. All right, so let's get into the document now. NGA, as I said, was the project manager of the document. There was input from a lot of the utilities in New York, and I'm talking about New York utilities and such, but it's a document that's intended to be used as a guideline across the country. So keep that in mind. The consultant for this was GTI. They had a lot of really good data that can be seen throughout the document that provides a lot of input. Okay, so many years ago, we started with manufactured gas and had a conversion over to natural gas, and now natural gas is second nature to us. We're looking upon a second great conversion for natural gas to renewables and incorporating renewables into our supply. Renewable gas is going to be an important part of the nation's supply in the future, so this document was created to address any issues with that. As with in the Northeast, with shale gas coming on board, there's a lot that needs to be focused on. You have to provide the appropriate attention to a new supply source and its capability of being interchangeable with traditional supply sources. And there are plenty of cleanup technologies that have evolved to make these projects work, so they are out there. So getting back to the document, it took about 3 years to get it done, almost to the day. There was a bunch of utility reviews with the utilities in New York State. The developer communities had some input on the document as well, which I think was really helpful in making it something that both parties can utilize. And we presented to the PSC and NYSERDA, and they gave it their blessing. They're really on board in New York with what we're doing. And it's kind of hot off the press. It just came out a couple weeks ago. I know there's a copy of it out on the AGA table outside if you're interested in looking into it a little bit further. And you can also find it at that website. Okay, so the science is there for these types of projects, but the policy isn't necessarily, as we've heard a little bit this morning. So RNG is already accepted and used in New York and across the US. The Staten Island landfill, which is in National Grid's territory, has been in service for over 30 years, probably closer to 40 at this point. And developers are ready. Developers have like I said, they have the technology. They're ready to inject into our system. It's just kind of the policy and framework to get there. Right now, there really isn't any consistent approach for certainty. No really consistent process to ensure the safety and reliability of the system and the continuity and interchangeability of the gas being injected. So going back to school days, do a little problem solving. Whenever you're trying to solve a problem, you consider the what, the why, and the how. So what are LDC's concerns? Why are LDC's concerns? And how can we address them? And this document tries to lay all of that out for us a little bit better. So the what? There's BTU values, specific gravity, total inerts, moisture, oxygen, sulfur compounds, all this stuff that we're used to seeing in typically source gas, as well as some trace constituents and supply reliability. So what are the reasons for monitoring these? There's a couple of reasons for monitoring them with typical sources as well as these new renewable sources. Interchangeability of gases, system integrity of the materials, safety and end use for both the gas system and the customers, and supply balancing. Okay, so here's where that good GTI data comes in that I mentioned before. This is a constituents of concern summary. It is located in the appendix of the document, and I keep telling people I think that the appendices of the document are as good, if not better, than the main portion of the document. I think there's a lot of really good information in them. This is one of them, this chart. It's a matrix that shows reasonable constituents of concern by feedstock. So a lot of data over years was pulled together by GTI, and they formed this little visual, and it's there to help save time, money, and worry. If it's not in there, you don't need to test for it. Use common sense when going about this. If you are more comfortable testing, ensuring that it's not in your gas, and then there's no reason to test further. Here's more GTI data. So this is another one of those appendices that I was talking about. It lists the AGA 4A reported range and some ranges of constituents found in natural gas samples in the pipeline today. And Then some data that was taken from different feedstocks. So you see landfill, dairy, and wastewater treatment plants are listed here. With the technology today, there is no reason why the white columns cannot look like the red columns. With the technology there, we can make this happen, and we can incorporate renewables into our system. And again, back to the why we're testing for this, why we're looking at all this data, it's for interchangeability reasons. So back to our problem solving exercise, this answers the question of why. Okay, so now moving on to the how. How do we make these projects successful? I think the most important thing is having a foundation of a good relationship between the developer and the utility. I think it's really hard to make these projects work without both parties being on the same page. There's ways to work together and say a collective yes to doing these projects rather than forgetting all of that science and the common sense that we've been talking about. And it's important to understand where the other party is coming from when you're working through these projects and react based off of that. Okay, so what does an RNG interchangeability process look like? The document tries to lay this out for us, and it looks the same as any interchangeability process. So the first thing you need to do is understand the historical supply, know the gas that's in your system currently, and then that is your pathway for moving forward. Understand the zone of influence that the RNG gas is going to affect. So the developer working with the utility to model the system and see, who's going to be affected by this gas. Where is this gas going to reach? And then in that zone of influence, determining any potential sensitive receptors. So we like to use the example of a bakery. Say there's a bakery or some industrial customer that has gas that has equipment that may be sensitive to fluctuations in, say, BTU value or something. Pinpointing those in that zone of influence is really important because if you're sticking to within utility gas specifications and pipeline quality tariffs, you're covering the vast majority of appliances that residential customers are concerned with. So these sensitive receptors are the ones you really need to focus on. And then do an assessment of those. So see, are there any retrofits that are needed? Work with the developer, work with the owner of the equipment, see, how can we make this work? How can we make it so that you can also accept this renewable source? We're trying to incorporate these into our area. How can we make it work for everyone? And then the last step is signing that interchangeability gas sales agreement with the developer that lists all of those gas quality specifications, lists the startup sampling and continuous sampling protocols and all of that stuff. All right, so now I have a couple slides on how to ensure success with these projects. So it's important to keep in mind that the tariff values do not always necessarily equal the LDC values in the system. They may be stricter, the LDC values. It's important to understand your specific system's gas quality and dynamics when doing some of these projects, and use blending. So, for example, the Staten Island landfill that I mentioned before goes into a transmission system. There's plenty of takeaway capacity. There's plenty of blending. So there's not terribly much concern there. It's been operating successfully for, like I said, almost 4 decades. Whereas we have a Newtown Creek wastewater treatment plant project that's going into our distribution system that is currently in construction. And that one, the planning team had to model the system and pay closer attention because it was going directly into a distribution system with a little bit less takeaway. So that's really important considering what your historical gas can blend and with the renewable gas and taking it from there. And always work together. No one wants the plant to be offline. The utility doesn't want the plant to be offline. The RNG facility doesn't want the plant to be offline. Working together is really important. Share as much information as possible to make sure that doesn't happen. All right, a couple more things. Optimize your startup and operational monitoring protocols. Startup sampling is really important. It gives you your baseline for what your plant process is looking like. Each one of these projects is like its own child. You kind of have to learn how the child is growing and developing and treat it that way. You're not going to, raise all your kids the same kind of thing. And another important thing is surrogate monitoring can be an indicator for other constituents. So, for example, CO2 is something that all of our GCs monitor. We have continuous data on the constituent carbon dioxide. Whereas for, say, the wastewater treatment plant, we're not continuously monitoring for a trace constituent, maybe something like siloxane. So what we do is, if the process is the process. So if your CO2 levels are rising, you can kind of get an indication that maybe some of your other stuff is also a little bit elevated, and you can take action based on that. So there's not a need to necessarily monitor for everything all of the time, but you have these good indicators that then you can determine whether you want to step further and take the step further and monitor and test for some of those other trace constituents. And if there are any anomalies, it's important to have a plan in place, work together, develop a utility, to create a response plan, to create a monitoring plan that both parties agree upon. And to close, I just want to say I focus on gas quality at National Grid. That is one of my main focuses. And I wouldn't have accepted the opportunity to present in place of NGA if I didn't think this was a doable project in a safe, reliable way for my own gas system, serves my family, my friends, and I think it's doable if you kind of do it the right way. So thank you, and pass it on.
Excellent. Thank you. Gus? Good morning. I'm going to see if I am as good a button pusher as my previous panelists, and it appears I'm not. So
Needs to get used to a new person.
Can we get some assistance with the slide? Working on it? Okay. Hang on.
all the jokes I know are about renewable natural gas, and you guys don't want to hear those, so we'll have to wait a minute here. So as we're waiting to get that going, again, my name is Gus Simmons with Kavanaugh & Associates. Hey, we got a slide here. And I've had the opportunity to work as a project developer. I've had the opportunity to work with utilities that are trying to figure out how to deal with interconnection requests, including having the very first external conversation that a utility ever had with a potential RNG developer, which was a lot of fun. And then I've also had the opportunity to work with lenders and investors as a third-party reviewer of projects they are looking to put capital into that would rely on an RNG connection. So I share that with you because I love this topic. I love the topic of lessons learned from those experiences. And I don't know that I'm going to be able to tell you anything that you don't already know, but at least be able to share in your pain. And we've got a room full of folks that have been able to do that. The key thing is it shouldn't be painful. And I am 100% convinced it absolutely does not have to be painful. And it really boils down fundamentally to one of the topics that both the previous speakers have discussed, which is communication. There are a lot of folks in the country that are trying to get this figured out. They're trying to figure out how to develop RNG projects and bring RNG into to our use in a meaningful way. There are folks who are utilities that are trying to figure out how to manage this process, how to deal with requests, how to position themselves to move forward, accepting this very valuable fuel supply. And then there are a lot of folks who have feedstocks and have opportunities to bring materials into the marketplace in a new and meaningful way that supports some of our very critical existing industries like agriculture. I don't know about you guys, but I enjoyed my breakfast this morning. And so finding ways to continue to support that industry through being able to harvest energy products and fuels such as renewable natural gas is incredibly important. And so I think bringing all these things together in our conversation this morning is going to be helpful to us all. One of the things that I wanted to make sure to leave you with, to think about, is communication is a confidence building process. And a couple of my friends in the audience have heard me soapbox about confidence building before, so I'm not going to drag them back through that. But what I mean in that is the initial conversations quite often begin with interested parties, a utility or a developer, and they're sort of spewing facts at each other, and they're spewing conditions at each other. And quite often we find that those aren't entirely fully vetted yet. And so when I say it's a confidence building process, quite often it's better to start with questions than with statements. Let's get to know each other. Let's get to know what each other's expectations and goals are, and let's begin to identify the unknowns that we need to work on together. Having the predisposition that we've got to have it all figured out before we begin to communicate is a bad idea for everybody involved. What that does is it tends to put us all in a position of taking positions that we may reflect on in the future were maybe not the best position to take. Or maybe that position wasn't fully understood yet to be able to make a well-informed decision about how best to proceed. The other thing that we need to acknowledge is the RNG industry is both an old and a young industry. As the previous speaker mentioned, we've got some projects that are 40 years old now. We have technologies that have been around since the 50s and 60s. And then we also have new innovations that are helping make RNG production more cost effective, more efficient, safer, better, more reliable. And so that process of innovation certainly opens us up to questions that need to be asked among the interested parties trying to get an interconnection. So I'm not going to read all of these. I've listed some of these down on the bottom of the slide. But again, the thing I want to leave with you is this process is about building confidence in a working relationship, in a business transaction between a producer of RNG and utilities that may be receiving that. I'll speak with my developer hat on for just a moment. Even if I tell you I know everything, I don't know everything. There's things that we got to figure out in that process. And so creating that comfortable environment for us to have that conversation and again, ask each other questions about how confident we are in the process, how confident we are in the projections, and being understanding if the answer is, well, we think it's here, but we need to have this discussion to be able to refine that and get a little bit further down the process. Some of the common misplaced expectations we've seen, both in projects I've been directly involved in and projects that I've helped others review and identify ways to close gaps in risk. From the developer's perspective, there's sometimes a belief, as we mentioned earlier, that the tariff and gas specifications are standard, that if we find a tariff published somewhere, that's got to be able to apply to me. And of course, we all know that's not the case. Big misconception, of course, that you guys have dealt with for a long time is the belief that an interconnection can occur anywhere there's a pipe. And obviously, we all know that's not the case, particularly taking a look at existing capacity and who may be served by that pipeline downstream. There's also a belief in the industry that there are established interconnection processes so that you can pick up the phone and I can call a utility and say, hey, can you give me the form to fill out? I'm interested in getting an interconnection in your utility. Some places have that, and obviously other places don't. Interconnection costs. This is a big deal for developers to be able to take the next steps, to be able to answer some of the questions you have and provide a high confidence level in data. Project developers often need a pretty good idea of what their cost structure is going to look like to even be able to take the next step of putting forth a feasibility study or vetting some of the data. So that's an important thing to establish up front. Again, even if it's a starting point, even if we identified as on a scale of 1 to 10, we're sort of a 5 at what this interconnection cost is going to be. And as we work together, we're going to continue to build confidence and refine that together. And then finally, some misunderstandings and misplaced expectations on the speed and simplicity of that process. What I commonly see for utilities is really a belief that RNG is more closely paralleled to the flows and expectations from fossil gas. So again, getting that understanding of how these systems are driven biologically and what their production variability may be, if any at all. Some of these systems are very constant and very continuous. Some of these systems have some degree of flow variability based on the biological process or the agricultural process or changes in the wastewater plant or opening a new cell in a landfill. All of those things can affect the flows and create some range in those flows. A big misplaced expectation is that RNG is inferior to conventional gas. I'd share with you that in some ways it's better than conventional gas. In other ways, it can be a challenge based on appliance use or those downstream customers that we talked about that have very specific requirements for the gas that they're using for a manufacturing process, as an example. They also, another misplaced expectation, again, is that stage of completion for the developer. Again, that belief that when the developer comes to you, they've already invested all the money it takes to give you very finite, very complete, very high confidence answers. If we got to that point, it's probably not going to go that well. The conversation needs to be happening much sooner. A misplaced expectation on estimated costs versus actual costs, and being able to identify that up front so that we understand areas that we need to work on and refine cost accuracy. And again, that same common misplaced expectation on speed and simplicity of the process. So ways to avoid that, again, communicate early. I know that we are all extremely busy, but I promise you that taking the time to communicate early and get those expectations and get your questions on the table are going to save you time down the road. Having to go back and readdress change conditions or readdress your way of thinking based on new information that has a higher confidence interval. So having a process to be able to accommodate those conversations, to me, is critically important in your interconnection process. And a lot of times we focus on sort of the process flow diagram. You know, we have this form to fill out, we do this feasibility study, we do this interconnection study, and we get to the back end. I love the previous set of slides identified having that communication plan, having the ability to set expectations for these are when we need to communicate, not just exchange paper to get this process down the road. Another big way to avoid misplaced expectations is actually to seek out each other's fears and concerns. Don't just assume because I didn't share with you something that I have as a fear or something that I have as a concern that doesn't exist. Sometimes we need to ask that of each other and say, hey, you know, here's where we are in the process. I think we've got a good game plan going forward. What is your fear of what could derail this process? What are the things that we still have unresolved that we need to identify and work on together to get this business relationship in place? Of course, establishing an interconnection process, if one doesn't already exist, it could just be this communication plan as a start. That's a great way to start, in my opinion. And then as you deal with more and more projects and you identify ways to streamline your process, of course, to create a more rigorous, more robust process for processing interconnection requests and applications. And then lastly, kudos to everybody in the room for being here and being part of this conversation, becoming more informed, sharing your thoughts and ideas and experiences with others in the group to help us collectively be able to improve and become better at getting these interconnections in place. Excuse me. I'm going to sort of zip through this last slide so we can get to our next speaker. So some of the considerations, this is a repeat of some of the information that you saw on previous slides. Again, it's the type of information that we need to exchange to begin this conversation and begin our ability to work together as a utility and as a developer. Certainly being able to map out the process and understanding that there's going to be elements of that conversation that are sensitive business information, both for the utility and for the developer and others involved. And finding ways to be able to deal with that and communicate that sensitive business information as it pertains to getting the project in place. Standards considerations, this is largely a repeat of some of the information that you saw, so I'm not going to spend any more time on that. But again, I appreciate the opportunity for us to have this conversation about the lessons learned and the things that we're all doing to continue to make this an easier and more improved process for everyone. And I look forward to your questions at the end of our discussions this morning. Thank you.
Nate,
Yeah, thanks.
I want to move the mic closer.
All right, while we're waiting for the slides to load here, I'm Nate Taylor. I'm from SoCalGas. By way of background, I guess SoCalGas has really been engaged in the biomethane space for over a decade now. We've also been engaged with taking producer gas onto our system, so like traditional local producers onto our system for many decades. We have something on the order of about 40 producers connected with our system. So we have a pretty long-standing and well-adjudicated process in California for interconnecting supplies into our system. Over the last decade or so, we've been able to kind of modify that to accommodate biomethane. And I think that most people in this room that have looked at this have probably seen the California standards that have come out of that process. So the rest of my panelists have done a pretty sufficient job, I think, of going through some of the process and considerations about interconnection. I'm going to try and keep this presentation a little bit higher level and maybe focus on some of the policy around interconnection in California and a little bit of the history. And I'll touch a little bit about our process at SoCalGas as well. So, excuse me. So for a little bit more background on just kind of the philosophy behind interconnecting. So SoCalGas exists to deliver gas to consumers, not necessarily to take gas onto our system from producers. It's kind of a convenience that we have pipelines in place where there are RNG supplies and other traditional supplies available. And we do provide non-discriminatory access to those producers to come onto our system. But it's at their own cost. It's not at the cost of our ratepayers traditionally. And even if we at SoCalGas felt strongly that RNG is something that we want to support, we want to give everyone a free ride for RNG interconnection, there are regulations in place to make sure that we're providing non-discriminatory access to all producers and that those costs for them to get their product to market are borne by them, not necessarily our ratepayers. So I think there are some important philosophical issues there that I think a lot of times producers struggle to get their head wrapped around. Why are they paying so much for these interconnections? It's not to say that that market's not evolving, and I'll talk a little bit about some of the policies that are changing, that are allowing subsidized interconnections for renewable natural gas, and we're very supportive of that. But it's kind of a difficult conversation sometimes. So when we talk about an interconnection, we're really talking about typically two different things or two different items. One of them is a pipeline extension. That's the amount of pipeline lateral that needs to be installed in order to get from the producer site to the nearest site on our existing system that can accommodate that capacity of gas that needs to be injected. So that's one cost, is that pipeline extension. And then the other cost is kind of the point of receipt or the metering and quality control kind of facility. So we usually talk about it in two different kind of elements. So over the last 10 years or so, as I said, we've tried to work closely with the biomethane industry to try and make this process a little bit easier and educate the industry on what's required. We actually have an RNG toolkit or a developer toolkit on our website. This is publicly available. It has some just basic educational material on renewable natural gas. It also overviews our process for interconnection. So starting with what we would call a capacity study, which is basically if you're a prospective renewable natural gas producer or just traditional gas producer, you'd say, I have this flow of gas at this location. Can you tell me where the nearest site on your pipeline is that I can accept, or that you can accept my gas, and a rough estimate of what those costs would be so that you can make kind of an early business decision to move forward or not. From there, we go into a preliminary engineering study and a more detailed engineering study, and there's kind of a maturity level along the way that you kind of pay for as the project matures. And it gets, at the end of that road is a fully permitted, issued for construction kind of design to install that interconnection. Some of the other things in there are biogas supplier lists. So we have customers that are interested in different vendors that can provide services around biogas upgrading or consulting services and different things like that. We have a list of service providers that have come to us and asked to be on our website. We provide that in this kit, as well as kind of a summary of our Rule 30 gas quality spec, which is like the California biomethane specification is contained in that rule that everyone's kind of familiar with. So there's just kind of a nice, glossy sheet summary of that rule as well. So starting to dive into the policy and the evolving policy in California a little bit. So as I mentioned before, the costs for interconnecting with our system are borne by the producer. In a few years ago, or actually it's starting back in 2012, AB 1900 was the first bill in California that really tried to look at biomethane injection standards. Within that bill back in 2012, it did mention the cost of interconnecting and how the CPUC can actually address those costs. It wasn't until several years later that they had a phase 2 proceeding that actually established an interconnection incentive where biomethane producers, if they prove that their system is operating and it's flowing gas consistently onto our system, they can actually get a refund. Originally, it was $1.5 million refund, up to 50% of their costs. There was another bill passed, I believe, 2 years ago in California that enhanced that, so that now the incentive is $3 million for any renewable natural gas project, up to 50% of their costs for interconnection. And the basis of those costs includes the final product compression equipment, that utility point of receipt, and the utility pipeline extension. When you look at dairy projects in California, it actually includes all of those costs, plus the capital cost of the gathering lines. So I know Daryl Moss was talking about his cluster project in California. So when you look at the actual capital cost of installing those biogas pipelines, that can be included in the calculation of this incentive, and they can qualify for up to $5 million of a refund once they've shown that their project is successfully connected. So going into a little bit more of kind of the policy history in California, I mentioned AB 1900 back in 2012. That's what really kicked off the biomethane standard and kind of codified it in our tariffs. From there, I think we can jump to 2016, SB 1383. This is actually a short-lived climate pollutant, so like methane, black carbon, refrigerant gases, a bill to actually reduce those emissions in California. But there was a recognition within that bill that dairy biogas coming from dairy manure is one of the key sources of methane in California. So there was a recognition that in order to facilitate that, California needed to adopt a pilot program to interconnect 5 dairies at least with our system. The CPUC last year actually selected 6 dairy projects. SoCalGas is helping with 4 of those projects to interconnect. And those projects will actually have full cost recovery in our rates of their interconnection, including their final product compressor, and they'll get a rebate for all of the biogas gathering collection line costs as well. So that was a pretty important policy, and it's going to be an interesting test to see how that can facilitate some additional market development in that space. The other 2 items in 2016 were AB 2313, so that's the bill that modified that incentive from $1.5 million to $3 million and $5 million. SB 840 was actually a bill that the biomethane industry mostly championed in California, and we were supportive of it, to have the California Center for Science and Technology take a look at the biomethane standards to see if they were overly onerous or anything like that. The result of that study was that the BTU standard was relaxed a little bit in our Tariff Rule 30. From 990 BTUs per SCUF at a minimum to 970. They also looked at siloxanes and some other issues, and they didn't make any modifications based on that study. And then in 2018, we had some pretty landmark legislation, I think, with SB 1440, which is really the start of a biomethane procurement program potentially for California, where we can actually go and buy above market renewable natural gas for our portfolio. And help support the market in that way, much like the RPS targets have helped renewable electric generation. I think that probably covers the key stuff here. So SoCalGas, or Sempra, I guess at large, currently has 3 RNG projects interconnected. The first one is the Point Loma wastewater treatment plant. That's been interconnected since 2012. That's down in kind of the San Diego area. The second project came online 2 years ago, I believe, or last year, middle of last year, the CR&R Waste and Recycling Services Facility that's in Paris. That's actually a project where CR&R is a waste hauler in Southern California, and they actually collect food and green waste from the communities they serve, and they put it in a purpose-built digester out in Riverside County, and they convert that food and green waste into biogas and RNG, and then they put that RNG on our pipeline and they use it in their waste hauling fleet. So it's a really nice kind of circular economy that solves several problems. And then the most recent project is the project Daryl was talking about earlier, which is the Calgren Dairy Fuels up in Pixley, California, connected through that ethanol plant that he mentioned. So that came online earlier this year, and we actually delivered that $5 million rebate check a few weeks ago to the company for interconnecting. That's it for me.
Great. Thank you. I'm going to have a few questions, but I welcome questions from the audience. There are microphones down here, so just come on down. Don't be shy, and I'll call on you when you get down here. One thing that I'd like the panelists to do, if you could, I'm curious about, since I haven't had a chance to dive into the NGA interconnection standard yet, and there was some comment about the developers not necessarily being totally happy with the California interconnection standard. Can you compare and contrast? What are the differences? What are the developers complaining about in the California version? Is that cost, that upfront cost, perhaps?
Sure. I mean, so the upfront cost is one thing, and I think that it's beginning to be addressed through these incentives. There's actually one of the bills that I didn't mention there that was listed on that slide was it actually asks the CPUC to consider fully rate basing RNG interconnections. So I think that from a cost perspective, we're on a path. I think some biomethane developers still view some of the quality specifications as a little bit onerous.
Yeah.
I hear sometimes issues around siloxanes with wastewater treatment plants and things like that.
Yeah, so they require siloxane testing for everything and not just for landfills.
So I believe the way that our system works is similar to the matrix that Melissa presented, we understand that, if there's not a pathway for siloxanes to get in the gas, we don't expect to test for it over the long term. But we do like to test for most things that we think could have any chance of being in the gas on kind of the upfront test, the startup test, to just make sure that it's not there. Things like siloxanes can actually come in through, cleaning products, shampoos and soaps and things like that. So even on dairies, sometimes you have, soaps or cleaning agents and things that could introduce siloxanes. You never know. But it's something that we'd like to just test for to be abundantly sure. But similar to Melissa, if we don't feel like there's a pathway for those constituents, we're not going to continue to test for those over time. So it just kind of depends. And I think we're trying to be as flexible as we can to work with developers in like a reasonable way, while also still protecting, our pipeline infrastructure as well as our customers and their end use appliances.
So Melissa, do you have any thoughts about what's different in the NGA approach?
So the NGA, it states, it's a guideline, so it's not a specification. So it doesn't provide the level of detail that California specification provides. It does give some ranges of numbers that say, okay, well, utilities aren't looking for 900 BTU gas, we're looking for more than 970 up range and stuff like that. But it doesn't actually, it lets the utility and developers work together on creating a specification and leaves it open for each developer to work with the utility.
Well, Gus, from your perspective, is it more difficult for developers to not have just, here it is, this is what I need to do, or is it better to have flexibility and to have that communication and walk through it and develop something that's sort of bespoke, custom made?
Sure, it's a great question. So I think you've got to have a starting point. And I think you also need to recognize that not all aspects of all of our systems are the exact same. And so as the great case in point, we were just talking about some of the gas constituents. You need a starting point to establish that upfront expectation, sort of an upfront contract between one another of, hey, this is the goal, this is where we're getting. But we also see systems that, produce exceptionally pure gas, that may have one component associated with it that is troublesome. And in those cases, I think most of the development community would appreciate the ability to have a conversation around that and see how that may be able to be worked into the system. And, as a great point, there's many sources of RNG that have no pathway to siloxanes. There's some that possibly have a pathway, and then there's some that have a known pathway. And so being able to have a conversation about those probabilities, and again, I hate to keep using this word, but the confidence that we have, the confidence interval on whether that pathway exists or not, and being able to adjust the expectations for monitoring and testing is very, very important. And I think there's several other constituents that I've seen discussed in other states and other utilities that, there's certain push points. I mean, there's certain utilities and certain groups that have expectations for really, really high BTU gas in certain areas of their system, but it might be okay to have a little bit different BTU in another portion of their system. And so having the flexibility to have that conversation and figure out what works best for both parties is incredibly important.
Yeah. I know in past conversations and workshops, we've talked about the issue, and you mentioned it too, the issue about having manufacturers, sensitive customers that need to have a certain parameter in energy quotient, so WOBE index, and I understand that there's, you mentioned just now, where the interconnect is, how close it is to those sensitive customers, and whether there would be enough blend. So are there some, in the guidelines that you have, and in California, maybe Scott, your experience, how do you figure out where to inject the gas? Where's the best place?
Certainly. There are a lot of factors where you look at where do you actually bring that gas into your system. For instance, if there is a customer that might be sensitive to a certain constituent of concern, you're going to look for a place, in those systems. Sometimes you might avoid that customer. Obviously, as a utility, we need to develop, or the way that Black Hills use it, we need to develop basically a standard gas quality requirement that we apply across the board. Now, that gives us the ability to work with our DEMP and TEMP programs as far as understanding the constituents of concern that could have pipeline safety implications. It also gives us a good way to work with developers on what we need. Now, every single project is different. And so that doesn't necessarily mean that, from the producer's system out that where they're treating the actual biogas, that does not mean that that's necessarily the same, but what we take into our system needs to be. So there can sometimes be some creative solutions where essentially what you do is you sell a certain amount of geologic gas to the producer and ensure that you have a certain blending ratio before it enters your pipeline. There are a lot of every project and there are a lot of other clever solutions out there that perhaps the problems haven't even been asked yet, or the questions haven't been asked yet. So with every project being unique, obviously there's still a need for consistency, but there's also a lot of room for creativity in addressing, how do we meet that need for consistency?
Yeah, that's great.
Can I come?
Yeah.
So, interesting lesson learned along that point. I just recently had a conversation with a group that were wrestling with this issue, and there was concerns over gas quality expressed to a developer from a utility because of a particular manufacturer that they were sensitive to their gas issues. And, we had these initial upfront conversations of, we can't take so much RNG because this customer has very specific requirements for gas. And we got the conversation going. And at some point, somebody said, well, hey, can we bring them into the conversation? We want to see, what their issues and needs are. And as it turns out, they have like 5 lines of product they produce. And the one that was critically important, the one that they were most concerned about gas quality, they were chucking in synthetic gas anyway because they needed a different gas composition than what was coming conventionally in the pipeline. And so, everybody was like, well, gosh, we just spent a lot of time, creating this potential, rift between us over the quality of the RNG. And as it turns out, they were quite happy that the RNG was going into the pipeline.
What a concept. So, let's call them.
Yeah.
Oh, that's great. We talked about communication and trying to get over misconceptions. I see in a lot of our panel discussions today, change management being really important. How do you get people over what they're comfortable doing? I mean, after all, what you've been doing day in, day out, it's just so much easier than figuring out some new thing where you have to be creative. How do you go about encouraging people to do this, to get involved and not block it?
So I think I think just providing the backup to your story is helpful. You know, seeing other projects, seeing the successes from other projects, providing data. I'm an engineer, science, providing the science behind why we're doing this. Pointing out that, you know, if we didn't do this before, we'd still be using manufactured gas. So this is just another level of doing that. And I think if you're providing people with the data and showing them logically that this can work, then they'll have a little rebuttal, I guess.
Any other thoughts on that? On the developer side, it may be also, I don't know if that enters in or not.
No, I was just going to echo Melissa's comment that I think getting people to buy in on this, and people have bought in, I think, pretty fully in this RNG vision. It's not to say that we can make any compromises around safety or system operation and things like that, but I think people are much more willing to work on these projects and give them the attention they deserve and make sure they're successful within those bounds.
Yeah. That's a good safe. Oh, go ahead.
I was just going to add, I think we have the development community, the investment community, and the utility community. We all have a very important common thread, as that is customer demand. And so we are seeing across the country the customer base for renewable natural gas and more sustainably derived fuels for their manufacturing processes or to serve their customers. They're really compelling us to get this figured out in a great way. And so there absolutely is an opportunity here for all of those parties to be exceptionally successful and serving a customer base who will be very, very happy that we get this worked out in an efficient manner. So I think that's the big common thread. And we've got to recognize that there's much more to be gained by helping each other and leveraging each other's experiences and intellect to get to that point. And that'll create streamlines and efficiencies for us to work together.
Mm-hmm. So you're talking about the high-tech companies, the Googles and the Amazons and all of that, who want renewables, big box stores, that sort of thing.
So those are the customers we all go to and think of because they write really, really big checks. But I'll share with you very briefly an anecdote. My teenager reads the back label of every piece of food she ever buys. She's not alone. I see a lot of the consumers that are coming into the market are now purchasing products. It's very, very important for them. It doesn't matter what it is, whether it's a chair or whether it's a pizza. They're very cognizant about how we delivered that product as a choice for them to purchase. So, yes, I think the Googles and the Amazons and those folks have been compelling the market in the beginning. But I think we're seeing just a cultural shift to a desire for these type of products in the marketplace. And so we're seeing a rise in a very large base of that customer expectation.
Mm-hmm. We have a few minutes left. If you have questions from the audience, come on down. Yep. You need a mic, or we won't be able to capture what you're saying, and nobody past the first row will hear you.
Do you mind if I make a couple of comments?
Of course, go ahead.
A couple of comments that I'd just like to make in regard to that last subject is definitely there is consumer demand. But when we look at this from the utility side, there is a comfort level that needs to be looked at. And just for instance, some of the projects that we started with were smaller projects that went into industrial areas where we look at the downstream customer, they're firing a boiler. Some very highly tolerant equipment with high dilution rates. And so that really helps to, mitigate the risks that the utility feels. And then you have, at this point, we're at 2.5, almost 3 years of experience where we have good, solid data coming from our instruments, coming from laboratory tests. And so we're able to develop that comfort zone. So, and not every project is ideally suited like the one that Black Hills was lucky enough to work with, where you do have that customer that goes into an industrial area with relatively unsensitive equipment. But when you can start out that way, definitely do. And then as also we look forward in the RNG market right now, these projects are being driven by basically the vehicle fueling market. Well, again, let's take some small steps. So at this point, we're simply buying the commodity gas. When everybody's feeling more comfortable with taking that, the molecules themselves and trusting the processes and the way that we're monitoring our gas quality, we can step into the next phase, which would be essentially possibly delivering gas to customers, actual renewable gas to your teenage daughter that wants to read the back of the label.
Yeah. It's great. Did you want to?
First of all, for Nate, I know you said the CCSD report, as a result of that, we reduced the limit for BTU. And what it said was we could reduce the BTU limit if we didn't compromise the WOBE number. So what we're really saying is that the WOBE number is a much better measure of the interchangeability. So we didn't give anything, we didn't concede anything, we didn't relax our standard. We really just made the standard probably more appropriate. So I will, you know, our limits have been set for good reason, and we might update, revise our limits. What we generally do, you know, we don't relax our limits. And I work for PG&E, so I worked a lot with May, so I think I can speak for both of us. The other thing is, as far as some of these different limits for different suppliers, I mean, I think our system is huge, as is yours. So if we have a different limit for every person who wants to come on our system, can you imagine gas control or any of us monitoring that? Oh yeah, that guy's 1.3, that guy's 2, that guy's, you know, we have to have some limits we just say universally apply, whether like it's our water limit of 7 pounds. And also, as far as protecting the really sensitive customers, we don't protect our most sensitive customers that, you know, because Bloom Energy, for example, I know they have to treat the gas before they use it. So I think it's generally safe to say our gas, our gas is safe for all of our residential customers. The bigger guys, generally it works for them, but there's going to be a few outliers. So when we're considering who is downstream, I think we take that into consideration somewhat, but not, it's certainly not the only consideration. And that sensitive guy downstream may be gone in 2 years, replaced by somebody else, or the gas flow direction might change. So we have to be careful what we use. But in general, it's a heck of a lot easier if we have one standard and we apply to everybody.
Makes sense.
Okay, thank you.
Yeah, I have so National Grid, personally, we have a gas quality specification, and we do not have a separate one for renewable sources. And any of our developers that come to us saying, hey, what's your gas quality specs? What do your gas quality specs look like? We give them that specification. And working through each individual project, we can then determine what the best way to proceed is with each developer. We're not, just throwing darts at a board here. We do have our gas quality specification. So I agree with everything you're saying. And as far as the downstream customers, we look at the zone of influence. So we look at all of those saying, hey, the residential customers can accept our gas quality specifications. The majority of them can. And we won't reject or accept a project based off of any sensitive receptors. We work with them, as you said, kind of, call them up. We've done that with one of our developers. We called them up. We said, hey, with one of our RNG projects, we called up the sensitive receptor and said, hey, we have a project coming online. And they worked with us on it. So I agree with everything you're saying, and just kind of emphasizing that, you have to take things as you go, kind of with your specifications in place.
Just to add a comment, I cannot imagine the nightmare of having a different spec for every interconnection. I mean, that would be horrible. But there are systems out there that are large enough or complex enough or different enough that certain areas may have different appetites. And that's what I had mentioned in my comments, was there may be areas within your system that you may have different concerns. And, my recommendation is to start with a base and probably not necessarily go down from that base, but you may have areas actually that are even more sensitive, that you have, different requirements for whatever reason. So, but yeah, I would not wish on anybody having a separate spec for every one of your interconnections at all.
Do we have any other questions? I think we have room for one more. Yeah, come on down. I think next time we'll have more mics in the back. We didn't know we were going to have this many people.
Back to Scott's point about developing your constituents list and a standard constituents list. I think that's kind of where we're at UGI right now, is trying to finalize that. So Melissa, the document that came out from NGA was really helpful with the guidance. But I guess when it comes to certain constituents like semi-volatiles or halogens, ketones, different things like that, are there sampling methods already set for those? Because I think that's what we're struggling with. Like, how do you analyze those?
So there are sampling methods. I don't know if they're listed in the document, but there are a couple of labs. I know GTI is one of them. There are a couple of sampling companies that you could probably reach out to labs that can do the test for you. There are ways out there to measure it. It's usually go out, take a sample, nothing really online continuous for a lot of that.
Natural gas though, because I thought they were mostly for stationary combustion sources, like your volatile metals or mercuries, different things like that.
Yeah, I believe we've been using a lab that I can talk to you later if you want, and kind of see if we can find anything else. And we talk back and forth with the developers, so we will typically suggest a lab, and the developers will say, yeah, that's we can use their lab. Here's the method we're using, and we kind of lay out that in the beginning.
And then how about any RADs or radiological contamination? Is there anything that we're looking at for monitoring for that?
Give me your information and I will get back to you on that.
Okay.
I'm trying to imagine how that gets into the dairy flow, but anyway. All right, I think that's, we're just on our time, and want to thank our panelists for a great discussion, and set us up for the afternoon discussion on technology too. Thanks very much.
Thank you.